All right, so now we're going to move on to methods, and I'm going to send you this in the chat. I want you all to pull it up, work through it with me. It's pretty straightforward. We did methods last semester. Methods are basically a block of code. It helps you organize your code, right? It helps you put some type of code that you want that has a specific purpose organized separately so that anybody come on after you or even yourself knows what that code is doing. Another purpose of a method is to put code in there that you're going to reuse in your program. So for example, with our ATM program, say for example, a user can deposit and then deposit into another account, right? But that happens somewhere else in the program. Well, I will put that deposit in a method and I can just call that method whenever I want to use it. And I'll show you that in a second. So the way we create a method is pretty straightforward. We have static void my method. Right? The reason that we have static here is so that we can call it from our main method. So if you look over here, our main method is public static. Static is a Java keyword that specifies that there are no other methods like this in the whole program. As soon as you create the program, it gets stored in memory. That's it. There are no other ones that you can use like that. So that's the purpose of a static method or even a static variable. When you have a static variable, it gets stored in memory. There are no other variables like it. It is it. Whereas down here, so I have this int option, right? This is not a static variable. I can have an int option up here, 6, and these two are completely unrelated, right? They have different scopes. However, if I have a static int up here, static int option up here, now I can't use this. I'll have to do this right here. So anywhere in my program that has this class, this static int will stay the same value, right? So wherever I call it in here, option would have the same value. So that's the purpose of the static keyword. It keeps that value, and we'll talk about that more as we get into classes and objects. But basically, this is how you create a method. If we look at this, let's create a method for viewing account balance. So of course, we have those keywords, and it's called the method signature. Public, static, void. We're not returning anything. View account. And then I want to pass in the balance. And I'll show you in a second what I mean with static variables. And then we just do right here. This is how we view the balance. Print that out down there. Then we close that method. There's no return statement. There's nothing else. All right. So now up here, all I have to do is call view account and pass in the balance. All right. So you could do it this way. Another way is to have that static balance. So static double balance equals 100. So now I don't need this one right here, right? Because that's static up here, I don't need this either. I can call it from down here because it's a static balance plus it's a class variable, so it's accessible anywhere inside this ATM class. So if you look at this bracket right here, the closing bracket is down here. That means any variables that I declare up here are accessible anywhere inside those two brackets. And I'll show you that. Let's run this program. So the first one is the PIN number, and then whatever transaction they want to do, and then exit. Oh, where are we at? Public. All right. Where are we at? Oh yeah, they changed that back. Where are we at? All right. There we go. All right, so of course, the first line would be to create that static variable, and that variable gets stored in memory as its own value. You see static fields, ATM.balance. So the class is ATM, and .balance is a static variable of ATM. And you notice it's outside of our main method. So this kind of blue box right here is the scope of our main method, right? That balance is outside that scope. But you see this scanner object is inside of our main method. Same with the pin. So entered pin, we read in 1, 2, 3, 4. Entered pin equals 1, 2, 3, 4. That if statement jumps down to this else and breaks. So now we're down here. So while true, we do all of that. We're going to read in this first option, which is a 0. So it doesn't equal 3. It jumps to our case 0, view account balance, and then it prints that out. And you see, I didn't have to pass in a parameter here because this balance is a class variable, right? And so it automatically has access to that. And even if you look right here, so view account, now that's the scope of our method right here. And there are no variables that we declared inside that method. It returns void. So now it goes back to our main, breaks. We do this over again. Read in the option, which is 3. We're going to break and end our program. All right. You see that method really made this a lot cleaner, right? Our switch statement, all our switch statement does is call those methods, right? So I'll do the same thing for case 0, case 1, and case 2. All I need to do is call those methods. So case 1 would be to withdraw. So let's make a method that withdraws. Public static void withdraw. Again, I'm not going to do any parameters because I want to do all of this right here inside that method. So this withdraw method would have all that code. To do a withdrawal. And inside my switch statement, all I have to do is call my method, withdraw. All right, and now this switch statement becomes a little bit cleaner, a little bit more concise. And now all we do is call methods to do the same thing, but those methods have a specific purpose, and we know what that purpose is just by reading the name of those methods. Let's make one for deposit, public static void deposit. Let's add this code in there as well. And all we have to do is call deposit up here. So if you notice, this just makes our code a little bit more organized. So if you look at each step in our code, it has a specific purpose. This part right here, or actually right here, is responsible for our PIN, making sure we enter the right PIN. This step right here is to do all of our transactions based on our user input. And then for each option, we just call our method. And so each one of these methods have a specific purpose as well. This one is to view the account. This one is to withdraw. And this one is deposit. And this feeds into the point I was making before. You can reuse code throughout your program. So if you see here, system.out.println, this last line right here, it's basically the same thing as what we're doing with view account up here. So instead of typing this code out, I can just call view account from down here. and that'll jump up to this method and print out our account balance. Same thing here. We do view account. So it makes our code reusable because I can call this method view account anywhere in my program, anywhere I want to. So let's try this. Let's see what happens. So let's do a 0 to view account, a 1 to withdraw from the account. Let's just draw 50 bucks. A 2 to deposit. Let's deposit 250. And then let's exit out of there. All right. So this one does need a scanner. So I'm going to pass in my scanner. All right, I'm calling this input.nextDouble. So I do need to pass in my scanner object in order to do that. So the formal parameter would be a scanner. All right, that way I can use it in this method. So up here, I create my scanner object to read from the console. Down here for this method, I pass in that object so that I can use it in the method right here. In order to do so, I do need a formal parameter in order to take that object's value so I can use it. Let's visualize this code. First thing again is create the static double balance. And another good point that this is showing is this program, it doesn't seem to be doing a whole lot, right? We're taking in a user's PIN, we're checking to make sure that it's the correct PIN. Then we're asking the user for different options based on their account, whether they want to view it, withdraw, deposit. Very straightforward program. But you see, it's starting to get kind of long, right? We have 71 lines of code on something very simple. So a lot more complex program with interchanging parts, and you have to connect to another person's program, it can get very long. So those methods help to organize it as well. Again, right? When I look at these methods, I know exactly what they're doing. This one is to view the account. This one is to withdraw. This one is to deposit. I know exactly what they're doing. So let's run through this. First part is to create that balance, 100. Then we create our scanner object. Again, the scope is within our main method. We create the PIN. The scope is within the main method again. System.out.println, enter your PIN. We read in 1, 2, 3, 4. Store it in this variable entered PIN. Entered PIN equals 1, 2, 3, 4 within the scope of our main method. That entered PIN is correct, so we break this while loop right here. Then we ask the user for their options. We read in the first option, which is a 0. It's not a 3, so we don't do this if statement. We go down to view account. So now we're in a new method. System.out.println, all that good stuff right there. You currently have $100 in your account, right? Then we jump out of that method, return value is void, and we go back to our main. Go out of there. We ask the user again. We read in the option, which is a 1, so that should be a withdrawal. And if you notice, when we go to this method, we're going to pass in this input object down here, okay? Boom. So you see, inside of our withdraw method, that input right here points to the same object that our main did. This is actually pretty good to visualize this. It points to the same object. So that's the same scanner. It just has 2 different pointers to it. So in programming, in operating systems, whatever you have something called a pointer. And basically what that does is point to a object or a memory address. So stored in that memory address, you can have many different things. You can have data, you can have an object, you can have some type of variable, and you have pointers to point to that memory. And so that's what we're doing. We're pointing to this object. It's the same object in memory that we were using up here. Right? It's the same object in memory. we just point to it in our method now. So within this withdraw method, we're going to print out how much would you like to withdraw. We say that down here. Then we create a double withdrawal amount. We read it in from the console as 50. Get down here. And you see, again, this withdrawal amount is within the scope of this withdrawal method. We cannot access this variable inside our main. We do balance minus equal withdraw, and you see balance changed up here. Then we call view account. And that's going to jump up to this method. Boom. We print out the account balance down here. You currently have $50. Return value is void. It goes back to withdrawal. Then that return value is void. Then it goes back to our main. All right. So methods, they go sequentially. So if I call withdraw from my main, it goes there. If I call view account from my withdrawal method, it goes to view account, and then it goes all the way back up. Think of it like a tree, right? So the top one is the main method. Then we go down to deposit or withdraw. Then we go down to view and back up. Okay, so it's all connected. We do this again. Ask the user for the input. This time I'll put a 2 in. That means to deposit into our account. So we call our deposit method. We ask how much they want to deposit. We read in that value. Again, this is within the scope of my deposit method. We view the account. It jumps up to this method up here, prints that out, goes back to our deposit method, back to our main, and we break. Do this all again. We read in a 3, and that's to exit, and we're done. All right, any questions about methods so far? Any questions? That was a lot, I realize that. And there's just a lot to programming, and there's a lot of things you can do with programming. But again, these methods down here make it very easy to organize your code, right? I had all of this code right here inside this switch statement, and although it worked, you know, if I was just to go back and look at somebody's program and I saw that code, it might not make as much sense as having all of these different methods down here, because now I know exactly what these methods are doing, and it helps me try to find bugs in my code as well. So if I'm running through this program, I'm using it, and I realize, okay, for some reason when I deposit, it's off by, you know, $1. I can go directly to this deposit method and figure it out. Instead of having to look through all of this code to try to find the error, I can just go straight to this deposit method and look for the error. So it helps you debug your code as well. All right. So I talked about methods. I talked about calling a method. So that's what I'm doing right here. I'm calling these methods in my program. So what I want you all to do is click on Start the Exercises. And I want you to do exercise 1, exercise 2. Let's see, exercise 3. I did talk about parameters. Actually, let's just do 1 and 2 right now. All right. I'll give you 5 minutes to do those. Exercise 1 and exercise 2. I put the link in the chat, and just go scroll all the way down, click on Start the Exercise. And again, if none of this makes sense or I'm going too fast, just slow me down. I don't mind going slower. I don't mind answering questions. You know, although there is material I have to get through, I'm more concerned with you all learning it and actually knowing what you're doing than just pushing through the material. And remember, we do have an assignment due on Sunday as well.
Yeah, for the assignment, we don't do the binary conversion, right?
The assignment shouldn't be. It should be this right here.
Yeah,
Is
on
it something
Moodle,
different on Moodle?
yes, sir. On Moodle, it says binary conversion.
Yeah, you
I
are
know
not.
we did that last semester.
Yeah, you are not doing binary conversion. I think I just need to change the name. Oh no, I actually got to change everything. All right, let me fix this.
Yeah, I had already did the binary conversion on Moodle. I ain't know we weren't supposed to do that.
You weren't supposed to do that. Let me fix this. This is actually the one you're supposed to be doing. All right, I fixed it. If you already submitted, you should be able to resubmit this right here. Switch statements and methods. It shouldn't be too difficult. You're just converting from different temperatures. And again, your program should work for any of these options, 0, 1, 2, or 3. And if anybody wants to use this Java Visualizer for what they're doing so they can see what's going on, all I do is Google Java Visualizer and I click on the first one. All right. It's really good for seeing like what is occurring in memory. That's why I use it. And I'm actually thinking of hosting this on our website as well, so that's more accessible. If anybody wants to take on that project to learn how to manage servers and how to get a web server running, let me know. It's actually a pretty good experience. All right, let's see this. So for exercise 1, insert the missing part to call my method from main. So what do you need to type down here in order to call my method?
My method.
My method. There you go. That's a good answer. All right. Let's put this in the visualizer so we see what's happening. So again, all you do is call my method. And so, of course, in programming, if you don't have a static variable up here, the first thing you do is go into your main. We call my method, it jumps up to my method in memory, it executes, I just got executed. Return value is void, this is the return value. We jump back down to our main, return value is void, and that's it. All right, pretty straightforward. Exercise 2, how do you call my method 2 times?
It's like my method twice.
Yep. All right, I'm gonna start calling on people. I want somebody to talk at least one time each class. All right, so we just do my method twice, and it gets executed twice. So let's see what happens. We call my method one time, it goes up there, and my method does get created in memory. Prints out I just got executed, returns, goes back up there, executed again, returns, and we're done. All right. Parameters. So again, parameters is what you saw with the scanner before. You have your formal parameters and your actual parameters, okay? Your formal parameters are what you put into the method signature. So formally, this is what it should be. I am expecting a string, and inside this method, I'm going to call it fname. Your actual parameters are what you actually pass to that method. So I pass Liam, Jenny, Anja. So when I call this method up here, fname will equal Liam, fname will equal Jenny, and fname will equal Anja. So let's visualize this. All right, so the same thing up here. Again, fname, the formal parameter, will equal these actual parameters when we run the program. So the first time we call it, Liam. So you see fname equals Liam inside the scope of our method. And we print out Liam. We return void, go back down here. The next time we call our method, the actual parameter is Jenny. So our formal parameter, fname, will equal Jenny. We run back through this. The last time, our actual parameter is Anja. So our formal parameter, again, fname will equal Anja. We print that out. Go back to our main, and we finish our program. So those are pretty much parameters. You can have multiple parameters, so fname and age, and this is how you do it with actual parameters down here. So then we have return values as well. So you look at these methods, void is the return value. The return value always goes right before the method name. So void, my method, and main. However, say I want to return an integer. So we pass in a value, a 3, and I want to return 5 plus 3. So that's what our return value would be, an integer. So edit. So you see here, static int, so this method is expecting to return an integer. And we're taking in a formal parameter x, we add 5 to x, and we return that value. Inside of our main, we're just printing out whatever is returned by this method. So we call this line right here is doing system.out.println, then it calls my method. So it's going to call my method before it prints out. So it jumps up here. Again, the formal parameter, x, equals our actual parameter. So x equals 3. We return 5 plus 3, which is 8. Our return value is 8. If you remember before, our return value was always void. Then we print out 8, and that's it. This program is pretty straightforward. If we look at our ATM program, let's say here, instead of void, we return a double. Return, let's do this. So double previous balance equals our current balance. Then we subtract the withdrawal amount from our balance, and we want to return our previous balance for whatever reason. We just want to know what that previous number was. So if we run through this, run through all the same things. We create our balance right here. We create our input object. We read in our PIN. It's the same, so it works. do this, read in the first option, which is 0, to view the account. We'll print out that number. And again, view account has a void return value. So return value is void, which is basically nothing. You have to put a return value though. You have to put that it returns something. The next option is a 1. So it's going to go down to withdraw. So let's go to withdraw. You print out how much would you like to withdraw. The withdrawal amount equals 50. That's what we read in from the console. Our previous balance equals our current balance. So 100. Then we subtract our withdrawal amount from our balance, right? So now our current balance equals 50, but our previous balance was 100. We call view account. It prints out our current balance, goes back to our withdrawal, and now our return value is that previous balance, so 100. You see this withdrawal has a return value, even though we're not storing it in anything up here. We just keep going. All right. So those are parameters and return values. Okay. Then of course you can have if statements inside your methods, just like you can have an if statement inside, your main method. And that's what you'll be doing in this program for your assignment. And what I would recommend is to have a different method for each of these. So Fahrenheit to Celsius is one method. Celsius to Fahrenheit is another. Celsius to Kelvin is another. And Kelvin to Celsius is another method. And so I would just have a switch statement for each one of these options. Inside that switch statement, I would call these individual methods. Similar to what I've done over here. I have a switch statement for all these different options, and based on whatever option they choose, I call that method. Right? I would do the same thing, except for you all, it would be Fahrenheit to Celsius, Celsius to Fahrenheit. And basically what you would do is this equation and print it out. Right? So first you would ask which conversion would you like to do? And then inside your methods, you would ask, please enter the value in Celsius if you're converting from Celsius to Fahrenheit or Celsius to Kelvin. Do the equation and then print this out. Okay. So right now, I want you all to do exercises, I think 3 and 4. Yeah, do 3, 4, and 5. Just finish off the rest of the exercises. I'm going to call on people to answer this, so hopefully you're doing it. Exercises 3, 4, and 5. All right, exercise 3. Add a fname parameter of type string to my method and output John Doe. So Gabriel, how do we do this? What do we have to put in here?
You just want me to like say what goes in this box?
Yeah.
So I put capital S string and then F name.
Yep.
Because when I first did it, I didn't know how to be capitalized. So, and then I put F name again in the last box.
Perfect. Yep. Perfect. All right. So who do I want to call on? Jordan, does your mic work? Jordan, are you there? If you don't respond, I will mark you as absent. I'm assuming you're not here. All right, Panache, what do I got to put here?
Return.
You said what?
Return.
Yep. All right. And last but not least, Mike, this is yours. What all we got to do here?
All right, you gotta put check age. Then you gotta put int age.
Mm-hmm.
Then if age, open mouth.
I'm assuming that's open
18.
mouth.
Yeah. 18. Else. Then you gotta put check age 20.
Yep. Perfect. All right. There you go. All right, everybody see what I did there with the exercises? Everybody clear on those methods? All right. So I was just putting together what you have to do for your assignment. I'm going to update this too. So I want this to be a 4 is the last option, and a 4 is to exit out. But basically, I started doing this for you. So you would have your system.out.println 0 for this conversion, you know, all the different options for conversions. Then you'd have this one, if option equals 4, you want to break out. And I'll just do the first one. So like I was saying, I would, if I were you, do all of these in a method. You don't necessarily have to. You can put all of these inside your switch statement, but I personally would put them in a method. So I would have a public static void Fahrenheit to Celsius method. And then I would pass in the temperature, I guess. Actually, I wouldn't even have to pass it in. I can read it in the console. And then from here, I would just call that method Fahrenheit to Celsius. And I would do all of the things I need to do down here in order to do that conversion. So like I was saying, you'd have to read in the Fahrenheit value, then you'd have to do the conversion, and then print out what the Celsius value is. Then your program repeats until the user enters in a 4 right here. And I'll just repeat this method for all of these different conversions up here. Any questions about the homework?
No, sir.
All right, cool. Like I said, I am going to update it because right now it doesn't have that 4th option, but just assume 4 is to exit.
You said the 4th option is to what?
Exit.
Exit. Oh, okay.
Exit. And I'm going to try to post this lecture and all the previous lectures. I'm going to try to post those today so that you have those at your disposal. All right, that's it for today. I will see you all on Monday, I guess.
All right, have a good day.
You too. Have a good weekend, everybody.
Have a good weekend, sir.
Have a good one.